Algebra 1, Lesson 28 and 29. First, we'll be looking at solving equations with variables on both sides of the equation, and then we'll be solving literal equations, which means that we have more than one variable, and we'll be able to solve for just one of those variables by isolating it. First, we have some steps to solve these equations. Now, this is going to be good for any equation that you need to solve. Okay, so these steps are extremely important. First, step 1, if there is distribution that needs to happen, do it. Next, we need to combine like terms on the same side if we have them. Next, we will move our variables to one side, move the constants to the other. Of course, we use opposite operations to do that. And then lastly, we need to solve for our variable, oftentimes with multiplication or division, something like that. So if we look at this example right here, we have 3 times the quantity 2x plus 1 plus 2x equals 5x plus 12. First, like our steps say, we need to distribute. And we're going to take this 3, multiply it to the 2x, and the 3 to the 1. So that we have 6x plus 3 plus 2x equals 5x plus 12. And then we look and see, okay, on the left side, is there anything that we need to combine? And we would say yes. The 6x and 2x are like terms, so we need to add them together. So that we get 8x plus 3 equals 5x plus 12. Well, step number 3 says that we need to move our variables together. I always like to take the smaller of the two and move it to the other side. This means that I will be working with positive coefficients rather than negative. So to do that, we need to subtract 5x from each side, which means that we get 8x minus 5x, so we simplify to get 3x plus 3 equals 12. Then we do the same thing, but with the constants, and this 3 is still stuck with the x, so I need to move it to the other side by subtracting by 3. By doing that, we get 3x equals 9, and we need to solve. Well, we have multiplication here, so we need to divide to be able to solve. Okay? So all of those steps are necessary to figure out these solving with equations on both sides. Now here's another example that we have. Okay, 19x plus 8 minus 8x equals 4 times the quantity 5x plus 2, and then we add 36. Well, like our steps say, our first thing that we need to do is distribute. So I'm going to do this 4 times 5x. Sorry about that. Let me erase it really quick. Okay, 4 times 5x. It's not wanting to play very nice today. Let's see. One more last shot. Let's see if it'll work. 4 times 5x and 4 times 2. Okay, let's see why that's happening. All right, let's see if we can get rid of this, because I do want to show this without a bunch of lines all over it. All right, this is going to go away in just a second. All right, let's see if this will work now. Almost there. Okay, let's try that one more time. We need to distribute first. So, wow, this is really messing up today. All right, just bear with me. It'll be over in just a second. Okay. So, we need to multiply out. That's what we've been trying to do. And we get 19x plus 8 minus 8x is equal to, well, we multiply out and we get 20x plus 8 plus 36. Okay, well, we then need to combine like terms on their same side. Well, that means that this 19x and this negative 8x become an 11x plus 8 equaling, well, the 20x doesn't have any partners on that side, so we need to add together the 8 and the 36. So we have 20x plus 44. And then we say, okay, I want to get all of my variables on the same side. Well, this 11x is smaller, so I'm going to subtract 11x from each side. And we get 8 is equal to 9x plus 44. And then we say, okay, this 44 needs to go away, so we subtract it. and we get negative 36 is equal to 9x. We divide by 9, and we get negative 4 is equal to x. Remember that we can always check our answer by plugging that negative 4 back into our original wherever I see x. Okay, another example here. Remember, we need to distribute first. Okay, so let me just change the color really quick. Okay, so I'm going to distribute out, and I get 8p minus 32 minus 6p is equal to 20 plus 4p plus 24. Remember, I'm going to distribute that completely. So we combine like terms on the same side, which means 8p minus 6p is 2p minus 32 equals, well, 4p doesn't have any partners, but 20 and 24 can combine to 44. Well, let's move some variables. I'm going to subtract 2p, and so I have negative 32 equals 2p plus 44. I subtract 44 because it's attached right now and I don't want it to be. I want to get rid of it. So I get a negative 76 equals 2p. When I divide by 2 on each side, I get p is equal to a negative 38. Okay, negative 38 is p. So if we were to plug that in, we could figure out if we got the right answer. Let's create a couple examples right here. So let's say, let's roll this dice, roll this one. Okay, so my equation is 1/2 x plus 6 equals 8x. Okay, so let's write that out right here. Hopefully. 1/2 x plus, there we go, 1/2. Well, we might be able to get this. Okay, just bear with me. 1/2. It's trying, folks. Okay, well, regardless, when we do this, we can move that 1/2 x to the other side. By doing that, I'm going to have to subtract it. So I would have 7.5 x equals 6. Okay, and then I would divide by 7.5 on each side and get x alone. Okay, big idea here though is being able to create these type of equations, or take these word problems and create equations from them to be able to solve. So, telephone company A charges $18.95 per month for local calls and 4 cents a minute for long distance. To be able to show that as an equation, we would say something like, okay, $18.95 plus 0.04 per minute, right? That would be telephone A company. Telephone B charges $21.95 a month and 2 cents per minute. So we say $21.95 plus 0.2 or 0.02 a minute. That's telling me the total cost for the month, okay, depending on how many minutes of long distance I use. And then it says, for what number of minutes per month is the cost of the plans the same? So if we want these plans to be the same cost, I want them to equal each other, which means I have variables on both sides, and we're going to follow the steps to be able to solve this. So I'm going to subtract 0.02 m from each side, and I would get 18.95 plus 0.02 m equals 21.95. And then I subtract 18.95 from each side, and I get 0.02 m equaling 3. When I divide by 0.02, okay, and do that division, I get m is equal to 150. What this means is, regardless of the plan, if you use 150 minutes of long distance, they are going to cost the same. Similarly, let's look at one more example of this. A fitness center has a fee of $125 to be a member, okay? And you can say, all right, I want to be a member, I'm going to spend the $125, and then I only have to pay $5 per day to work out at the center. Whereas a non-member, they don't have to pay the fee, but they have to pay $10 each day to work out. So to be a member, I would say my fee is $125 plus $5 a day. Whereas to be a non-member, I would just be $10 per day. And if I want to know how long is it until these costs are the same, we would say I want them to equal. So I subtract 5D from each side so I can figure out, okay, what is D? We have 5D equals 125. So I divide by 5, and I see that at the 25th day, those costs are going to be the same. Before that, though, it would be better to be a non-member, okay, because it'll be cheaper. But after that, it is saving you money to be a member and actually pay that fee. So it depends on how many days a week you want to go to the gym. Now, looking at our next lesson in here, literal equations. We need to be able to solve for one variable in these equations that have multiple variables. Literal equations, we call these equations that have more than one variable. Things like that we see a lot, like the Pythagorean theorem. A squared plus b squared equals c squared. Or my equation for a line, y equals mx plus b. We could solve those for one of those other variables in there rather than just for y in this case. Okay? Let's try it for these two. We're going to take these equations and solve for y. What that means is we're going to use the same type of steps that we've been using, but instead of solving for y and having a number being the answer, we're going to have an expression being the answer that has the other variable included. So, to give you an idea of what this looks like, 2x plus 3y equals 10, we are saying, okay, if y needs to get a loan, then we are going to subtract 2x from each side. So that 3y is equal to 10 minus 2x. Okay? And then I say, okay, that 3 is still attached to the y. I don't want that. So I have to divide to get rid of it. So I could say y is equal to this expression up here. Or I could divide it out and take 10 divided by 3 minus 2x divided by 3, or 2/3 x, whichever way. So we solve for one of the variables. We can do it again, but in this case we have y solved for 1, but now we want it solved for x. So I need to get rid of this negative 5 by adding 5. Okay, remember I'm doing PEMDAS backwards in these cases. So we have y plus 5 equals a negative 3x. I divide by negative 3, and I see that x is equal to this expression here, or you could show it as a negative 1/3 y minus 5/3. Okay, there's lots of ways to show it, but we solve for the variable. Let's try it on a few other equations, like this one. We need to solve for r, but we see that r is on both sides, so let's first get them on the same side and then move everything else to the other side. So we have a 3r on the left and a 4r on the right. So I'm going to get rid of the 3r. It doesn't actually matter which way I do it, I will come out with the same answer. So on the left side I now have 2s minus 7 equals negative 4s plus r minus 8. Okay, now that we have all of our variables that we want on one side, let's get rid of everything else and move it to the other side. So that means I'm going to add 8 to each side. So I have 2s plus 1 equals negative 4s plus r. I'm going to add 4s, and I get 6s plus 1 equals r. And I have r completely alone. Let's try it one more time with a's and p's, maybe apples and pears. Okay, so I once again see that I have p's on both sides, so I'm going to get rid of this p on this side. And I have 3p plus 2a minus 5 equals 6a. Now that I have all of my p's on one side, I'm going to move everything else to the other side by subtracting 2a. So that I have 3p minus 5 equals 4a. I'm going to add 5. And I have 3p equals 4a plus 5. And I divide by 3. I'm just going through the exact same steps that I would in any other equation to get that p is equal to 4a plus 5 over 3. Okay, remember if you're dividing a side that has more than one term, you divide the entire side by that number. Now if we have something like this where we say, okay, our Celsius equals 5/9 of f minus 32, there's a couple ways to do this. Now I could multiply this out, and I'll show it in a couple different ways. I'm going to multiply it out first, distribute, and then move everything to the other side and solve for f. And then I'm also going to show you how to get rid of this 5/9 first so that it actually makes it a little simpler. So let's multiply it out first. I distribute, okay, and I see that I get c, let me just erase this really quick. I get c is equal to 5/9 Fahrenheit, and then I'm going to multiply again times this negative 32, which is really just doing like 5/9 times a negative 32 over 1, which gives me minus 160 over 9. Now to get f by itself, I add 160 to each side to get c plus 160 over 9 equals 5/9 f. And then to get rid of this 5/9, I can divide by it, or the same thing as multiplying by the reciprocal, 9 over 5. And I multiply the entire other side by 9 over 5, which means I get 9/5 c, remember, distributing out, and then I distribute again, which means that I am going to add 160 over 9 times 9/5, which means I can cancel out the 9s, and I can also say, all right, 5 into 160, that's just 32, and that equals f. So what I really have is 9/5 c plus 32 equals Fahrenheit. So that's one way to do it. Distribute out and then get rid of that fraction by multiplying by the reciprocal. Now there is another way that I want to show you that can come in handy pretty quickly. Okay, let me get rid of this. Okay, so let me try this one more time and we'll see what happens. Okay, so if I do this a little differently and say, I am going to actually undo that multiplication by 5/9 first, by multiplying each side by the reciprocal, 9 over 5. This sounds familiar because we did that earlier after I distributed. So I get 9/5 c is equal to, well, these go away and I just have f minus 32, which means all I have to do is add 32 to each side, and I get my answer, 9/5 c plus 32 equals Fahrenheit. Okay, so I get the same thing, but definitely with a lot less steps. So think about that as you're going through these. Let's try another one. If I have circumference equals 2 pi r, and I want to know what is the radius, well, radius has been multiplied by 2 pi, so I could divide by 2 pi. And I get my radius is c over 2 pi. I can do this with any formula that has more than one variable. Okay? And lastly, let's look at this. The Ramirez family is taking a trip to the coast. They live 270 miles from the coast, and they want to make the trip in 4.5 hours. Use the distance formula, distance equals rate times time, to determine the average speed the family needs to drive. Which means I want to take this formula, distance equals rate times time. Okay, here I'm going to move this for a second. And I want to change it so that I can figure out what is the rate that I need. Okay, what is the rate that I need? So if I do that, then I need to get r by itself. So I'm taking my distance equals rate times time, and I'm solving for r, which means I need to divide by t. So I do d divided by t equals r, which means all I need to do is figure out, okay, what is my distance, what is my time, which they gave us 270 over 4.5, and that will give me my rate. Makes it a whole lot easier. Well, I hope this was helpful for studying and for homework.